Good day, sir. We are Group 30 from the subject Database and Cloud Security. Here to present about our Summer 1. My name is Tan Ting Lee.
My name is Kitishan Laki Tambiraja.
And my name is Jabzilam Robbie.
So I'll be talking about task 1. So we have 3 objectives. So the first one is to develop a secure web-based employee management system. The second one is to enable comprehensive CRUD operation. The third one is to optimize data management. So our proposed design is firstly is presentation layer, business logic layer, and data layer, which is the database. So firstly, let me explain about the presentation layer. So we have HTML templates are used with Jija2 for dynamic branding of data, and then forms for user input are built with Flask WTF for robust validation. And then for business logic layer, Flask framework manage routes, form processing, and user sessions. And then secure authentication and session management are implemented for both administrators and employees. Password are hashed using bcrypt. So for data layer for database, we use MySQL to store employee records with proper normalization. Then SQL Alchemy as the ORM handles database interaction. And then auto-incrementing primary key for employee table with functionality to reset counter if needed. So our features is firstly is user role and authentication. So admin role with privilege to manage employees. They can add, they can delete, and so on. So for employee management, there is CRUD, which is meant for create, read, update, and delete. We can do all in once in our system. So for dynamic dashboard, will be the admin displays. Basically, the admin can see the list of employees which are in the system, which will be explained by my teammate Ting. So moving on to error handling. So proper error messages and feedbacks for invalid input actions are displayed also, which also will be shown by my groupmate Ting. So moving on. So implementation step. So we have 6. One is environmental setup, database design, back-end development, front-end development, testing and debugging, and deployment. So, Budam. So our proposed hardware and software to develop the application is a programming language. We are using Python 3. And then our framework is Flask. Our database is MySQL. Our environment is Windows 11 operating system. So system design in component interaction part. Firstly is client side, server side, and database. So firstly is browse, render the UI, and send HTTP requests. And then for server side, Flask processes HTTP requests, handles authentication, and performs CRUD, which was explained just now by me. So for database, it stores and retrieves data as per application logic. Okay, moving on. So what we use to plan to secure our database is to implement role-based access, use strong password, protect against SQL injection, and audit and monitoring.
So I'm going to explain about how the application works. So first off, we have the login page. So we have the login as admin first. So here's a admin employee dashboard. So here, right here, admin can add new employee. Let's say we add someone named, let's say someone named Kerr. And then we give him position of developer. Then password, we have to use at least 6 characters. Let's say if I use 3, then you need to lengthen this tag to 6 characters or more. Use 6. So right here, we have the ID, the name, the position, and the password is hash to protect against data integrity. So right here, we can log out, and we can log in as Kerr. So if I log in as Kerr, if I mistype the password, it will bring us to invalid credential. So the password, and then we can see the welcome Kerr and then the position. So Kerr as an employee cannot access the admin database. So let's log in as admin again. So admin can also edit any information about any employee. So let's say Ke got promoted. So we got senior developer. So here is the position is updated, senior developer. So if you want to add a new employee, so let's add Peter. Let's say we #r and then password we give 6 characters or more. So right here we got Peter #r. The password is #2. So as you can see from the MySQL workbench, so it's empty. If I run the command again, so you can see there's two row, same as this. And the admin can also delete. So let's say if I delete Peter. So Peter is deleted. And then I run again. So right here, Peter is gone. So and also we also have audit log implemented to record and protect the integrity of the company. So right here. So as you can see from here, admin log in successfully, and then admin added new employee Ke, and then admin log out, fail, log in again, and then log out Ke, and then update employee, added new employee, and then delete the employee. So we have the timestamp and the date too to further protect integrity. So steps taken to secure database, we actually hash the password stored in the database, and we also validated the input to prevent attacks like SQL injection and cross-site scripting. And we implemented the role-based access control. So employee cannot access this database and edit anything. Only admin is able to do that. And also we implemented the audit log and monitoring to track users' actions and error logs. So let's move on to task 3. So strike. So first one is spoofing. So how to mitigate that in our application? We use authentication, password hashing, and session management. For tampering, we use database validation, input validation, and access control. For repudiation, we use audit logs and logging. And also for information disclosure, we use input or output sanitization, we use encryption, and also we use access control. And denial of service, we use rate limiting. And elevation of privilege, we use role-based access control, session verification, and secure admin credentials. So for DRAG, for spoofing, the risk level is actually high. For tampering, it's also high. For repudiation, is medium. For information disclosure, is high. For denial of service, is medium. And lastly, elevation of privilege is high.
Okay, now I'll be explaining task 4. Okay, we have our first task is we have data users, that is admin, and HR manage employee data, and also data processors. Admin/HR directly controls the processing, storage, and management of employees' data. And lastly, we have data subject. Employees' data are being collected, held, and processed. Okay, next stage. We have PDPA 2010. As you can see, we have 4 stages, and not only that, we have how to achieve the compliance and personnel responsibilities and penalties for non-compliance. Okay, our first stage is collection. Now, how do we achieve the compliance is provide clear written notice to data subjects on the purpose of data collection and obtain explicit consent before collecting sensitive personnel data. Now, the personnels that are responsible are HR manager, IT admins. And then the penalties are up to 300,000 ringgit fine or 2 years imprisonment for violation. Now, next stage is storage. Use data strictly for the purpose stated at the time of collection and limit processing of sensitive data unless explicitly consented to. And the personnels are data users, and the fines are up to 500,000 ringgit or 3 years imprisonment for unauthorized processing. Okay, next stage is access and correction. Now, allow data subjects to access and request correction to their personnel data and implement a mechanism for verifying and updating personnel data. The personnel are customer support or HR. The fines are 100,000 ringgit or 1 year imprisonment for denying access. Next, the last stage is disposal. Permanently deletes personnel data using secure deletion tools, shred physical documents. And the personnel that are responsible are IT and record managers, and the fines are up to 300,000 fine or 2 years imprisonment. Okay, next. Okay, next task is first one will be authentication and access control. Strong user authentication, only authorized users, for example, admins can log into the application using secure credentials. Next is passwords are hashed with bcrypt before being stored, preventing exposure of plain text password. And then next one is least privilege principle. The Flask application connects to the database using a dedicated MySQL user with limited privileges. Okay, 3, data validation and sanitation. For example, input validation, form data, for example, of employee name and position. It's validated server-side using Flash WTF to prevent SQL injection and malicious input. Next is prepare statement. SQL queries are parenthesized queries with SQL Alchemy to avoid SQL injection risk. Okay, 5, encryption, password hashing. User passwords are hashed with bcrypt, which ensures they are stored securely and are hard to crack. And audit logging. Application level logs, application actions like user login, CRUD operations, and failed authentications attempts are logged to an audit file for monitoring and accountability. And lastly, we have protection against internal attacks, role-based access control. Admins and employees have separate roles limiting access to sensitive actions. For example, only admins can add or delete employees. And last one is internal activity monitoring. Audit logs monitor internal activities, allowing deletion of suspicious behavior from within the organization. And that is all from me and our group.
Okay, so that's all from us. Thank you, sir.
Okay, thank you, sir.
Thank you, sir.